Good morning, students. Our next topic is semiconductor electronics. So in the semiconductor electronics, we are going to discuss what do you mean by semiconductor. Then we are going to discuss the types of semiconductors, on what basis we have the types of semiconductors, that we are going to discuss here. Different materials. Then we have the biasing, PN junction. Yes. Then forward bias, reverse bias, what are the applications of that? So like this, the concepts are there in the semiconductor electronics. Now let us start here. In this semiconductor electronics, first we will see what do you mean by a semiconductor. So we know that the materials can be divided into three types here. So what are the three types of the materials? That is conductors. Then we have the insulators. Then semiconductors. So what do you mean by conductor here? Conductor is nothing but what? Which will allow the electricity to flow through them. The materials which will allow the electricity to flow through them, that is called as a conductor here. And all the metals are the conductors. Okay. Then insulators. What are insulators here? The materials which will not allow the current to pass through them, that is called as the insulator. The example, plastic we can take, wood, rubber, these are the examples. Then semiconductors. So semiconductor anta andre idardu conductivity enagutte antandre lies between, the conductivity lies between conductor and the insulator. So hege lies between agutte anta heltare, that is here at room temperature these semiconducting materials behaves like a insulator. Room temperature ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಅದು insulator ಆಗಿ behave ಮಾಡುತ್ತೆ. And when you increase the temperature, it behaves like a, that is conductor. It behaves like a conductor here. Okay. So that is the semiconductor here. So examples for the semiconductors. Can anyone tell the example for the semiconductor? We have examples for semiconductors. Yes. Damini, Abhishek, Jyoti, Kumar, Purvi, Rakshita, what are the examples? Yes, Rakshita is saying silicon, germanium. Damini, yes, that is example for semiconductor, that is silicon and the germanium. Silicon and germanium now example agi consider ಮಾಡ್ತೀವಿ. Okay. So if you see this silicon and germanium, what is the outermost orbit electrons? That is valence electrons. In case of silicon or germanium, how many valence electrons will be there? Valence electrons. Yes, in case of silicon and germanium, the valence electrons will be 4. Therefore, silicon matte germanium ge ನಾವು tetravalent anta ಹೇಳ್ತಾರೆ. This is called as tetravalent. Okay, this semiconductor is divided into two types. That is intrinsic semiconductor ಮತ್ತೆ extrinsic semiconductor anta ಹೇಳ್ತೀವಿ. So what is intrinsic semiconductor? Intrinsic semiconductor anta andre pure semiconductors are called as intrinsic semiconductors. ಈ intrinsic semiconductor ಅಲ್ಲಿ silicon ಮತ್ತೆ germanium ನಾವು example ಆಗಿ consider ಮಾಡ್ತೀವಿ. What is extrinsic semiconductor? It is a semiconductor whose conductivity will increase by adding some impurities. So impurities anna add ಮಾಡಿದಾಗ the conductivity of the material increases. Those are called as extrinsic semiconductors. Okay. So in extrinsic semiconductor ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಹೇಳಿದೆ ನಾನು, impurities add ಮಾಡ್ತಾ ಇದೀವಿ. So here we have two types of impurities, that is pentavalent impurity and the trivalent impurity. We have two types of impurities, pentavalent and trivalent impurity. So here the extrinsic semiconductors is divided into two types, that is N type of semiconductor and the P type of semiconductor. Yes. So N type of semiconductor and form ಆಗ್ಬೇಕಾದ್ರೆ ನೀವು ಹೇಳ್ತೀರಾ pentavalent ಬೇಕಾಗುತ್ತಾ trivalent ಬೇಕಾಗುತ್ತಾ? Yes students, ನನಗೆ N type semiconductor formation ಬೇಕಾಗಿದೆ. I'll add which impurity? pentavalent or trivalent? ಯಾವ್ದು ಆಡ್ ಮಾಡ್ತೀರಿ? Yes. So Jyoti and Rakshita, they are saying we will add the pentavalent. Is it correct? Correct. Yes. So here to get the n-type semiconductors, we will add the pentavalent impurities. We will add the pentavalent impurities. Similarly, to get the p-type of semiconductors, we will add the trivalent impurities. So what is the difference between n-type and p-type material here? That is the semiconductor. In case of n-type, we are adding the impurity as pentavalent. In case of p-type, we will add the impurity as the trivalent here. Okay, so in case of n-type of material, the number of electrons will be more. The number of electrons will be more. Same way, in case of p-type of material, the number of holes will be more. The number of holes will be more here. Okay. Now, here we will see some definitions like doping. So what is doping here? Doping anta andre nav ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, semiconductors ಅಂತಂದ್ರೆ germanium silicon ಗೆ impurities ಅನ್ನ add ಮಾಡ್ತಾ ಇದೀವಿ. The process of adding the impurities to the semiconductors is called as what? Doping. ಇಲ್ಲೇನ್ impurity ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, that is called as dopant ಅಂತ ಹೇಳ್ತಾರೆ. ಅದನ್ನ ನಾವು dopant ಅಂತ ಕರಿತೀವಿ. Okay, doping is the process of adding impurity. Dopant is the impurity what you are adding. Yes. Now here p-type n-type how we are getting ಅದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. pentavalent ಮತ್ತೆ trivalent ಬೇಕಾಗುತ್ತೆ ಅಂತ, ಹೌದಾ? ಸೊ ನಾವಿಲ್ಲಿ ಕೆಲವೊಂದು ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನ ನೋಡಬಹುದು. If you consider the trivalent, indium is the example, aluminum is the example, right? So similarly pentavalent also we can take like arsenic and all, we can take the examples here. This is about the p-type and n-type material. Okay, now let us go for the next concept. So in case of semiconductors, here what happens, that is, if you see the structure here, so we will take this is considered as the valence band. This is taken as valence band, and here I'll take the conduction band. So in case of insulators, in case of insulator ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ conduction band ಮತ್ತೆ valence band, they are overlapping with each other. They are overlapping with each other. Okay. Then next, in case of insulators, there is a large gap between this conduction band and the valence band. And in case of semiconductors, whatever the gap between the valence band and the conduction band is there, it is slightly less than the insulators. Aita? Matte ee gap ige enanta karitare? So the gap between the conduction band and the valence band, what it is called as, students? Yes, who is telling the answer? It is Damini. Yes, it is energy gap. The gap between the conduction band and the valence band is called as the energy gap. Yes, very. Then next we will discuss the p-n junction. So now we just stay in nodidvi, that is we have one type material, that is p type of materials, and we have the n type of material. So if I combine one p-type material and one more n-type material, so here the junction is created. Here the junction is created. The junction between this p and n type of conductor is called as what? Semiconductor is called as p-n junction anta heltare. It is called as p-n junction. So we know that in case of p type of material, the number of holes will be more, and in case of n type of material, the number of electrons will be more here. Okay. So when the potential difference is applied for this p-n junction, here what happens? The exchange of the electrons and the holes takes place. The exchange of electrons and the holes takes place here. So when the exchange of this electron and hole is taking place, here we will get one barrier. Here we will get one region anta kuda helabodu. We will get here one special region, and that region is called as what here? Depletion region anta karitare. So when I apply this p-n junction to the external source andre battery connect ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ here it will develop a region called as the ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ವಾಟ್ ಇಸ್ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್? ಇಟ್ ಇಸ್ ಎ ರೀಜನ್ ಇನ್ ದ PN ಜಂಕ್ಷನ್ ವಿಚ್ ಕಂಟೈನ್ಸ್ ಓನ್ಲಿ ಇಮ್ಮೊಬೈಲ್ ಅಯಾನ್ಸ್. ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಪಿ ಮತ್ತೆ ಎನ್ ಟೈಪ್ ಕೆಲವೊಂದು ಏನ್ ಇಲ್ಲಿ ಬಂದು ಅಯಾನ್ಸ್ ಇದಾಗತ್ತೆ, ಸೆಟ್ ಆಗತ್ತೆ, ಅದನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, ದಟ್ ರೀಜನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ಡಿಪ್ಲೀಷನ್ region. So the symbol for this PN diode, it is represented like this. Okay, so this is P type and this one is N type. Matte iden line ide, that is this line. If I make it little tilt, idanna ee tara madidre idu Zener diode uddu circuit symbol agutte. This is only for the simple diodes. It is only for the simple diode here. So now, as I told you, I am connecting my PN junction or my diode to the external circuit. This is my P type, this is my N type here. Suppose if I connect the P type to the positive terminal of the battery and N type to the negative terminal of the battery, this is called as forward biasing anta karitare. Similarly, if I connect the P type to the negative terminal and N type to the positive terminal, then this is called as the reverse biasing. So what is forward biasing? What is reverse biasing? So P type material forward battery do positive terminal ge, N type material battery negative terminal connect madadaga forward biasing agutte, and this is reverse biasing here. Okay, now in case of the forward biasing, the current will be maximum. In case of the forward biasing, the current will be maximum. To measure the current in the forward bias, we use milliammeters, and in case of a reverse bias, we use the microammeters because the current is very, very less here. Okay, so this PN junction now yadಕ್ಕೆ ಇದನ್ನ ಕಲಿತಾ ಇದೀವಿ, ಇಲ್ಲಿ ಎದಕ್ಕೆ ನಮಗೆ ಎಲ್ಲಿ ಅವಶ್ಯಕತೆ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, this PN junction is used as a rectifier ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. The P junctions are used as a rectifier and it is also used as a switch anta kuda heltare. So what is rectification here? The process of conversion of AC into DC. The process of conversion of AC into DC is called as what? Rectification. Rectifier antandre enu? It is a device which will convert that AC into DC. AC into DC. Okay. Then in case of a rectifier, we have two concepts, that is half wave rectifier and the full wave rectifier. So just main points ashte nan helta idini illi. So in case of a half wave rectifier, we can convert only half cycle of AC into DC. We can convert only half cycle of AC into DC. So DC anta andre direct current agutte. Okay, so this is DC representation. AC representation, it is changing the direction. Okay, so this is AC representation. What happens in case of half wave rectifier? Only half of cycle is getting converted into DC. This is half wave rectifier. What happens in case of full wave rectifier? The entire AC is converted into DC here. And the difference between half wave rectifier and the full wave rectifier is, in case of half wave rectifier, we are using single diodes, and in case of full wave rectifiers, we are using two diodes here. Okay, this is regarding the half wave and the full wave rectifier. Namge matte en jaasti en explanation bekagalla illi, because MCQs alli avaru nimge kevala idra mele questions anna kelo chances irutte aita. Then Zener diode. So what is a Zener diode? Zener diode is nothing but what? It is a device which is used, specially designed, actually idanna special agi design madidare. Yadakoskara anta andre to operate in the reverse breakdown voltage. So reverse breakdown voltage alli diode operate ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಇಲ್ಲಿ special arrangement ಮಾಡ್ತಾ ಇದೀವಿ. That special arrangement or the design is called as what? Zener diode here. So symbol and so this is the symbol for the Zener diode. Okay, this is the circuit symbol for Zener diode here. Then next, so this Zener diodes, we use it as a voltage regulator agi use ಮಾಡ್ತಾರೆ. Zener diodes are used as the voltage regulators. So what is the voltage regulator here? So whatever the input you are giving, same output we will get. Like that we are making the arrangement. So again, we don't require much explanation there. ನಮ್ಗೆ ಅಲ್ಲಿ ಏನಾದ್ರು question ಬಂದ್ರೆ ಅಲ್ಲಿ ನಾವು ನೋಡ್ತಾ ಹೋಗೋಣ ಮತ್ತೆ. Then next we have the photodiodes ಅಂತ ಹೇಳ್ತಾರೆ. So photodiodes ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ here, when the light falls on the diodes, here, it will give out the current that is called as the photodiode. When light falls on that, the current is liberated or current is getting generated. It is called as the photodiodes. Then we have the LEDs. What is LED? Light emitting diode. So what is the use of this LED? These LEDs are used in the TV remotes. These LEDs are used in the burglar alarms. Then these LEDs are used in the calculators. LEDs are used in the traffic signals. LEDs are used in the optical communications. So these are the uses of the LEDs here. Yes. Then the last point is about the transistors. So what is transistor here? So PN junction we are using one p-type material and one n-type material. But in case of a transistor, we are using three types of material. So either it is a combination of NPN, that is 2N material, 1P material, or it is a combination of PNP, NPN transistors and the PNP transistors. Okay. So in case of NPN transistors, that is 2N-type material ಮಧ್ಯ ಏನಾಗುತ್ತೆ P ಅನ್ನ ಸ್ಯಾಂಡ್ವಿಚ್ ಮಾಡಿರ್ತಾರೆ. ಇದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? NPN transistors ಅಂತ ಕರಿತೀವಿ. Like it is a sandwich. You can see that 2 bread pieces, they are N materials. This P is the stuffing here. ಹೌದಾ? So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? ಸ್ಯಾಂಡ್ವಿಚ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ. That is PN sandwich. So similarly PNP sandwich ಕೂಡ ನಾವಿಲ್ಲಿ ಮಾಡಬಹುದು. So PNP sandwich ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ? ನಮ್ದು ಬ್ರೆಡ್ ಪೀಸ್ PP ಆಗಿದೆ and N is what? N is our stuffing in the sandwich. ಹೌದಾ? So this is nothing but what? PNP transistors and the NPN transistors. Yes. So Lohit is asking the marks on this lesson. So minimum 3 up to 4 marks we can expect from semiconductors. Actually semiconductor ಮತ್ತೆ communication ಎರಡು ಸೇರಿ ನಮಗೆ 4 to 5 marks ಬರುತ್ತೆ. Semiconductors ಮತ್ತೆ communication. So last lesson ಇದೆ ಅಲ್ಲ, ಇದ್ರ ಮೇಲೆ 4 to 5 marks we can expect from both the topics together. Yes, this is about the PNP transistors and the NPN transistors here. So the PNP and NPN transistors can be denoted with the circuit symbol. So here one is called as the ammeter. The 3 regions are called as, one is ammeter, one is base, and one is the collector here. Suppose if I show the arrow mark, in the downward direction, this is PNP transistor. Suppose if I show the the arrow mark in the outward direction, then it is called as the NPN transistor. It is NPN transistor. So here we have the ammeter, we have the base, and we have the collectors. 3 regions irutte illi, ammeters. That is in case of transistor. So what is the difference between these 3 regions here? In case of a ammeter, it is heavily doped. So ಇಲ್ಲಿ 3 part ಅಲ್ಲಿ ammeter, base ಮತ್ತೆ collector ಅಲ್ಲಿ ಯಾವುದು ಜಾಸ್ತಿ ಡೋಪ್ ಮಾಡಿರ್ತಾರೆ? ಡೋಪಿಂಗ್ ಅಂತಂದ್ರೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ ಆಲ್ರೆಡಿ. That is an impurities adding process. ಹೌದಾ? So ammeter region is heavily doped and the collector region is lightly doped. Base ಏನ್ ಮಾಡಿರುತ್ತಾರೆ? Least doped. Base is the least doped here. Then the thickness size is less than the collector and greater than the base. Ammeter ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ammeter size base ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ but collector ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. Okay, so this is greater than base but less than your collector region. Similarly for the collector region, its thickness is more, and in case of base it is least. Base du kadme irutte, space kadme irutte aita. Then so what about the function here? Ammeters ಏನ್ ಮಾಡುತ್ತೆ? ಇದು ನಿಮಗೆ it ejects the majority charge carriers. ಅಂದ್ರೆ majority charge PNP charge PNP transistor alli majority charge carriers ಏನಾಗುತ್ತೆ holes ಆಗುತ್ತೆ. This emitter will eject the holes here. In case of NPN transistor, it will eject the electrons. ಹೌದಾ? What about the collector? Collector ಏನ್ ಮಾಡುತ್ತೆ? It collects the majority charge carriers from the base. Collector will collect, emitter will eject. What about the base? It transmits the majority charge carriers to the collector. It will transmit the charges to the collector anta navilli helbodu. Okay, so this is regarding the highlights of the whatever the semiconductor lesson we have here. We have the logic gates. First we will see some questions, then we will go for the logic gates. Okay, now last questions discuss madakinta munche truth table matte logic gate symbols anna discuss madana. Now we will go for the questions what we have, again same at the end, previous year questions. Okay, here actually the questions are little mixed with your communication system also. So we will go according to the sequence only. So communication system addu kelon questions il cover agirutte. Il nodi, the first question, the maximum distance up to which TV transmission from a TV tower of height h can be received is proportional to which of the following. So some questions are obtained from the communication system. ಏನ್ ಕೇಳ್ತಿದ್ದಾರೆ, the maximum distance up to which T transmission from a T tower of height h can be received is proportional to which of the following. So Harsh is saying option A, yes. So somebody may forgot the concepts. So we will see that is the distance is given by the distance is given by D is equal to under root of 2h into r. It is 2D is equal to root of 2h into r ಅಂತ ಕೊಡಬಹುದು ನಾವಿಲ್ಲಿ. ನಾವು ಇಲ್ಲಿ ನೋಡಿದಾಗ 2 ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, r is the radius of the earth, ಅದು ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. So your distance is directly proportional to under root of h ಅಂದ್ರೆ h to the power of 1/2. So option A is correct. Option A ಬರುತ್ತೆ, not D. Option A correct ಆಗಿದೆ, h to the power 1/2. Yes. Let us go for the next question. In communication with the help of antenna, if the height is doubled, then the range covered, which was initially r, would become. So what happens to the range if the height is doubled? Same formula melene barutte. That is given by the range is equal to under root of range ಅಥವಾ ಅದೇನ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ನಾವು ರೇಂಜ್ ಅಂತ ತಗೊಂಡ್ರೆ that is under root of 2rh is it is then ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ, it is doubling ಅಂದ್ರೆ 2r into bracket 2h. So what I'll do, root 2 I'll take it outside. root 2 ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ಒಳಗಡೆ ಏನು ಉಳಿಯುತ್ತೆ ಹೇಳಿ, that is under root of 2rh. So under root of 2rh is nothing but what it is, root 2 into r. So r dash is root 2 into r. Yes, anybody got the answer? Yes. So Pratibha, Damini, Harshita is giving option A. So option A is 100% correct. Okay. Then the next question, identify the layer where ozone is present. Where ozone layer is present? Troposphere, stratosphere, ionosphere and the mesosphere. Yes, correct, very good. That is Damini, Rakshita, Monica. Option B, that is stratosphere, students. So stratosphere alli namdu ozone layer ide. Okay, so option B is correct option here. Then the next question, Which of the following statement is wrong? Ground wave propagation can be sustained at frequencies 500 kilohertz to 1500 kilohertz. Option B. Satellite communication is useful for the frequencies above 30 megahertz. Space wave propagation takes place through the tropospheric space. Then fourth option is sky wave propagation is useful in the range of 30 to 40 megahertz. Yes. Ground wave propagation can be sustained. So Harshita is saying D. What about other students? Which is wrong. Yes, correct. Sky wave propagation is useful in the range of 30 to 40 megahertz. That is option D. Option D is correct here. Then the next question. What is the refractive index of the ionosphere? What is the refractive index of the ionosphere? So here in the ionosphere, actually here line agbekantandre, whatever the light rays are incidenting on the ionosphere, it will get refracted back. Howda? So namgili reflection phenomena agbekanta andre from the ionosphere namge reflection agbekanta andre otherdu refractive index 0 irbeka, more than 1, less than 1, or it should be 1. Yes, very good. So it is option C. Harshita, you are right. That is option C. Damini, that is less than 1. So namgili light to reflect back agbekadre namgili enagate, the refractive index must be less than 1. Very good. The next question. The biological importance of the ozone layer is to stop the greenhouse effect. So ozone layer ಏನ್ ಯೂಸ್ ಇದೆ ಅಂತ ನಿಮ್ಗೆಲ್ಲ ಗೊತ್ತಿದೆ ಹೌದಾ. So what it will do, it will protect us from the UV radiations ಅಥವಾ ultraviolet radiations. Yes, very good. It is false. The biological importance of the ozone layer is to stop the greenhouse effect alla. So it will protect us from the UV radiations. Yes. So by protecting that, no doubt later we can control this greenhouse effect and all. But ozone layer importance anta navilli ಹೇಳಿಕ್ ಬರಲ್ಲ ಹೌದಾ. So it is false. Next question. Identify the suitable frequency for the sky wave propagation. For the sky wave propagation, here option C is right. That is 2 megahertz to 50 megahertz. Option C anta ನೋಡಿ. Option C correct ಆಗಿದೆ ಇಲ್ಲಿ ಆಯ್ತಾ. Then the next question. Yes, what is the maximum distance up to which the TV transmission can be received if the TV tower at a height of 220 meters? So again from the same formula navilli calculate ಮಾಡಬಹುದಾಗಿದೆ. That is given by D is equal to under root of 2R into H. So we can take the radius of the earth as 6.4 into 10 to the power of 6 meter anta tagoli. Adanna tagondu ನೀವು ಇಲ್ಲಿ the maximum distance can be calculated. R value, H value is there. Calculate D. Yes, option A, B, C are correct. Other students, what is the answer? Lohit, Lakshmi, Mahalakshmi, Purvi, Pratibha. Yes, what is the answer? Only 3, 4. Yes, option C is correct. I hope everybody is getting the answer. Option C is correct. Then the next question. What is the physical of the atmosphere? Stops ultraviolet radiation, stops greenhouse effect, stocks increase in the temperature of the atmosphere, absorb pollutant gases. Yes, it stops ultraviolet radiation. Yes, very good, very good. That is option A is correct here. Then our next question. So this is not related here. Okay, this question is the manifestation of the band structure in the solids is due to which of the following? So band structure of the solid and the explain. Pauli's exclusion principle, Bohr's correspondence principle, Boltzmann law. So ಇಲ್ಲಿ Heisenberg uncertainty principle ಅಲ್ಲಿ ನಾವೇನು explain ಮಾಡ್ತೀವಿ, that is the momentum and position is cannot be explained simultaneously ಅಂತ ಹೇಳ್ತಾರೆ. So Heisenberg ಬರಲ್ಲ ಅಲ್ಲಿ because Heisenberg uncertainty principle is what, that is for a given electron position and the momentum cannot calculate the simultaneously. Here the manifestation of the band structure in solid is due to the option B, that is Pauli's exclusion principle. Can anyone write and tell me what is Pauli's exclusion principle? Enide ಹೇಳಿ ಅದು? The electron pairing or the electron, how it will take the orbits anta explain ಮಾಡ್ತಾರೆ. So what is that rule? Anybody remember what is the rule? Pauli's exclusion principle. Yes. Pauli's exclusion principle, it obeys 2n square rule. Haudala? Correct? That is 2n square rule obey ಮಾಡುತ್ತೆ. So that will be helpful for the explanation of the band structure of the solid. Then the next question. The energy band gap is maximum in which of the following? Metals, superconductors, insulators, semiconductors. Everyone can give this answer. Yes, correct. Everyone. Pratibha, Harshita, Rakshita, Vidya, Monica, Damini. Yes, very good. That is, in case of insulators, the gap is very large. At absolute zero, silicon acts as which of the following? At absolute zero, silicon acts as which of the following? Non-metal, metal, insulator, superconductor. Correct. That is at absolute zero, silicon ಅಥವಾ semiconductor acts like a insulator. Option C is correct. Then the next question. A piece of copper and another of germanium to 77 Kelvin. Okay, room temperature in the really cool material. What will impact on the resistance of each of them? So you have one copper piece and you have one germanium piece. Both are cooled from the temperature, room temperature to 77 Kelvin. What will impact on the resistance of the each of them? Each of these decreases, copper strip increases and that of germanium decreases. Copper strip decreases and that of germanium increases. Each of these increases. Yes, it is. Correct. It is option C. That is what? Copper strip decreases and that of germanium increases. ಯಾಕಂತ ಅಂದ್ರೆ ಇಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಮತ್ತೆ ರೆಸಿಸ್ಟಿವಿಟಿ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ, ಹೌದಾ? Therefore we can say copper increases. Option C is correct. Then the next question. In semiconductors at room temperature, Which of the following is likely to happen? The valence band is partially empty and the conduction band is partially filled. The valence band is filled and the conduction band is partially filled. The valence band is filled. Option D is the conduction band is empty. For semiconductor at room temperature, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ room temperature ಅಲ್ಲಿ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. Which option is right? So Praveen is saying it is C and D. Pratibha is giving option C. Yes, Harshita is right. That is option A. The valence band semiconductors room temperature ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, so ನೀವೇನ್ ಹೇಳ್ತಿದ್ದೀರಾ that valence band is empty, conduction band is empty, ಅದು insulators ಆಗುತ್ತೆ. But semiconductors at room temperature, the valence band is partially empty and the conduction band is also partially filled here. Okay, the option A is right. So once you increase the temperature, then it will conduction band will go on filling that one. So option A is correct. Then the next question, at absolute zero temperature, a semiconductor acts as a conductor. It is true or false? Yes. It is false, right? Sinchana. It is false, yes, right. Then the next question. Which of the following is true regarding insulators? The valence band is insulators ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಮುಂಚೆ ನಮಗೆ semiconductor ಸಿಗಿತ್ತಲ್ಲಿ. The valence band is partially filled with electrons. The conduction band is partially filled with electrons. The conduction band is filled with electrons and the valence band is empty. The conduction band is empty and the valence band is filled with electrons. Yes, option. The conduction band is empty and the valence band is filled with electrons. Option D is correct here. Option D is correct. Okay. Then the next question. Crystalline solids are which of the following? Anisotropic, isotropic, amorphous, unipotential. Crystalline solids are which of the following? I think ನೀವು ಇದನ್ನ ಸ್ವಲ್ಪ chemistry ಅಲ್ಲಿ study ಮಾಡ್ತೀರಾ ಅನ್ಸುತ್ತೆ. Yes, very good. That is anisotropic. That is option A is correct here. Then the next question. At which temperature a pure semiconductor behaves slightly as a conductor? At which temperature a pure semiconductor behaves slightly as a conductor? Low temperature, room temperature, high temperature, supercritical temperature. Here you people are saying that at high temperature anta ನೀವು ಹೇಳ್ತಿದ್ದೀರಿ. They are not asking that a pure semiconductor behaves as a conductor ಅಂತ ಕೇಳ್ತಿಲ್ಲ ಅವರು. Slightly behaves as a conductor ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. Slightly ಅಂದ್ರೆ little bit property it is showing. Yes, very good. So Nandish, Damini, Monica, yes, that is option B is right. That is at the ರೂಮ್ ಟೆಂಪರೇಚರ್ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ಹೌದಾ? ನೀವಿಲ್ಲಿ ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಸ್ ಬಿಹೇವಿಂಗ್ ಲೈಕ್ ಎ ಕಂಡಕ್ಟರ್, ಇಟ್ ಇಸ್ ಅಟ್ ಹೈ ಟೆಂಪರೇಚರ್, ಬಟ್ ಸ್ಲೈಟ್ ಬಿಹೇವಿಯರ್ ಅದು ಇಲ್ಲಿ ತೋರಿಸುತ್ತೆ ಅಟ್ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಇಟ್ ವಿಲ್ ಶೋ. ನಾವು ಈಗಷ್ಟೇ ಅದು ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ ಮತ್ತೆ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಅಲ್ಲಿ ಕ್ವಶನ್ಸ್ ಅನ್ನ ನೋಡಿದ್ವಿ. ಎಸ್, ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. On doping germanium metal with a little amount of indium, what does one get? Intrinsic semiconductor, insulator, N-type semiconductor, P-type semiconductor. Doping germanium metal with a little amount of indium, what does one get? Yes. So ನಮ್ಗಿಲ್ಲಿ ಇಂಡಿಯಮ್ ಪೆಂಟಾವೆಲೆಂಟ್ ಟ್ರೈವೆಲೆಂಟ್ ಅಂತ ಗೊತ್ತಾದ್ರೆ we can say this one. So here the indium is the trivalent, therefore we will get the option D, pentavalent material ನಮ್ಗಿಲ್ಲಿ ಸಿಗುತ್ತೆ. ಹೌದಾ? So option D is correct. Then the next question, in a pure semiconductor crystal, if current flows due to breakage of crystal bonds, then what is the semiconductor is called? In a pure semiconductor crystal, if current flows due to the breakage of crystal bonds, then what is the semiconductor is called as? Acceptor, donor, intrinsic semiconductor, extrinsic semiconductor. Yes. Pratibha, Harshita, Damini, Monica. Yes, very good. That is, it is intrinsic semiconductor. It is called as intrinsic semiconductor. Okay. Which of the following, when added as an impurity into the silicon, produces N type of semiconductor? So N type ಅಂತಂದ್ರೆ ನಮಗೆ ಏನು ಬೇಕಾಗುತ್ತೆ? ಪೆಂಟಾವೆಲೆಂಟ್. Yes, which one is the answer? Phosphorus, aluminium, magnesium, sulfur. Yes, Rakshita, Harshita, Kumar, Vidya. Yes, very good. That is phosphorus. So phosphorus is the correct answer. Option A is correct. Then next one, in N-type semiconductors, which one of the following is the majority charge carriers? Holes, protons, neutrons, electrons. N-type. N-type holes irutte. Holes. Yes, Vidya, Rakshita, Harshita. Yes, electrons. So N-type alli majority charge carriers will be electrons. And in case of P-type, it will be a proton, holes here, okay? Then the last question from this for today's class. Next, we will go for little coming this one, logic gates. A small impurity is added to germanium to get a P-type semiconductor. Identify the impurity. Bivalent, trivalent, pentavalent, monovalent. Yes, very good. That is trivalent. Trivalent is right. So again, further questions later tomorrow's class we can discuss. ಈಗ ನಾನು ಸ್ವಲ್ಪ logic gates ಮೇಲೆ ಒಂದು ಸ್ವಲ್ಪ ಹೇಳಿ previous year questions we will discuss. So little we will highlight about the logic gates now. So here so in the semiconductor chapter, we have at the end digital electronics we will study. So in the digital electronics, we will represent the analog representation, okay, with the digital values or the discrete values like 1 and 0. We take the values 1 and 0. ಅಥವಾ ನಾವಿಲ್ಲಿ ಆಫ್ ಮತ್ತೆ ಆನ್ ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ, ಹೈ ಅಂಡ್ ಲೋ ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. ಹೌದಾ? Here we express one equation to describe this, that is called as Boolean expression or the Boolean equation anta ಹೇಳ್ತಾರೆ. Then the truth table will be there. With the truth table is what? It is the possible output what we are getting from the input combinations, that is called as the truth table. So for our class we have the tables like we have the AND, We have OR gate, AND gate, OR gate. Then we have the NAND gate. Then we have NOR gate. We have XOR gate. Yes. So these are the gates which we will study for the 11th class. Sorry, 12th class. Aita. Illi AND gate alli. So this AND gate here, the representation of this AND gate is, this is AND gate representation. So this is my A input and this is my B input. So the output Y is represented as Y is equal to I A dot B. It is represented as A dot B. Okay. So this is the Boolean expression. Y is equal to A dot B. Now the truth table for this AND gate is the value of A, B and Y. So here 0, 0, Y will be 0. 0, 1, Y will be 0. Then it is 1, 0, again it is 0. If we have both the values high, the output will be high. This is for AND gate. Then for the OR gate. So what about the OR gate here? In case of a OR gate, the representation is, yes, this is our OR gate and the output representation is given as Y is equal to A plus B. It is given as Y is equal to A plus B. And here the values of A, B and output Y is, here it is of your AND gate, 0, 0, it will be 0. And all other cases it will be, it is 0. It is 1, 1, 1. And 1, 1 iddaga kuda 1 barutte, 1, 0 iddaga kuda 1 barutte, 0, 1 iddaga kuda 1 barutte. This is for your OR gate. Then we have the NOT gate kuda barutte. What is NOT gate here? NOT gate is nothing but what? Negation anta ಹೇಳ್ತಾರೆ. ನೀವೇನ್ input ಕೊಡ್ತೀರಾ ಅದರದ್ದು reverse ನಮಗೆ ಬರುತ್ತೆ ಇಲ್ಲಿ. Okay. This is Y is equal to A negation. That is, suppose your input is 1, the output will be 0. If the input is 0, the output will be 1. This is about the NOT gate. Now NOR and NAND gate we will see. That is, NAND gate is what? It is the negation of your AND gate. It is the negation of your AND gate. The Boolean expression is given A dot B to the bar. So here the symbol will be, allen barutte AND gate alli illi just straight line tagontivi, illi now negation anna tagondu Y is equal to our A dot B bar. So what about this truth table? So there, what is the truth table? There we got, it is 0, 0, 0, 1 and here it will be negation andre reverse barutte. It will be 1, 1, 1, 0. Similarly with the NOR gate. So what about in case of NOR gate? It is the negation of your OR gate. Negation of your OR gate. So the symbol will be the logic gate. For the NOR gate, it is like this. Okay, this is input and the output is this. So here what is the output? So actually we will get for NOR gate. OR gate it is 0, 1, 1, 1 anta bandre. NOR gate alli enagutte 1, 0, 0, 0 anta barutte. Okay, so this ನೀವು ಏನು ಮಾಡ್ತೀರಾ, you will study in your regular class. So now we will go for the previous year questions. So again tomorrow communication ಮತ್ತೆ semiconductors ಮೇಲೆ ಒಟ್ಟಿಗೆ ನೋಡೋಣ questions ಅನ್ನ. Now we will see the previous year questions. So the first question is, it is asked in the 2017, the energy gap in which of the cases less than 3 electron volt. The energy gap in the following is less than 3 electron volt. Options are germanium, iron, copper and the aluminium. So this is 2017 question. In which of the following the energy gap is less than 3 electron volt? Yes, it is germanium. Option A is correct. Then the next question. The question is, in N-type semiconductor, we have N-type semiconductor, okay? Electrons are the majority carriers, but it does not show any negative charge. The reason is, I'll repeat, in case of N-type of semiconductors, we know that electrons are the majority charge carriers, but it does not show any negative charge. Why? Options. Electrons are stationary here. Second option, electrons are neutralized by the holes. Third one, mobility of electrons is small. Option 4, atom is electrically neutral. So this is asked in 2014. Yes, Lohit is right. That is, it is neutral. Option D is right. Kumar of Lohit. Yes, it is. Option D is correct. Then the next question. So this is 2018 question. The density of an electron hole pair for a pure germanium is, the density of electron hole pair is given as 3 into 10 to the power 16 per meter cube at room temperature. On doping with aluminium, the hole density increases to, aluminium in the dope ಮಾಡ್ತಾ ಇದೀರಾ germanium ಗೆ, the density increases to 4.5 into 10 to the power 22 per meter cube. Now the electron density in doped germanium will be. So for germanium, what is the electron density? Options are 1 into 10 to the power of 10, 2 into 10 to the power of 10, 0.5 into 10 to the power of 10. Option D is 4 into 10 to the power of 10. So I'll repeat the question. The density of electron hole pair for the germanium is 3 into 10 raised to 8. Okay. Next, you are doing the doping by aluminium. The hole density increases to 4.5 into 10 raised to 22. Then, now what is the density of the germanium? Question is clear to everyone? 2018. Question clear aita? Where everybody went? You are calculating or what? The density of an electron hole pair is, for germanium, 3 into 10 to the power 16 per meter cube. On doping with aluminium, the hole density increases to 4.5 into 10 raised to 22. Now the electron density in doped germanium will be. Lohit is getting option B. What about others? Everybody is getting option B. Yes. So option B is right here. How to solve this one? So ಯಾರಿಗೆ ಗೊತ್ತಿಲ್ಲ ಅವ್ರು ನೋಡಿ. That is, we have one formula, that is the density of hole into density of the electron is equal to dc square. So dH into dE, it is, dH value is 4.5 into 10 raised to 22. Then dE as it is, which is equal to 3 into 10 to the power of 16 whole square. So DE calculate ಮಾಡಿ option B ಬರುತ್ತೆ ಆಯ್ತಾ. Option B is right here. So ಯಾರಿಗೆ ಗೊತ್ತಾಗಿಲ್ಲ, you can use this formula. DH into DE is equal to DC square. Simplify, you will get the answer option B. Then last question for today's class. Which of the following semiconducting device is used as voltage regulator? So which of the following semiconducting devices used as a voltage regulator? Options: laser diode, Zener diode, solar cell, photodiode. So 2017 question. Yes, it is Zener diode. So option B, Zener diode is correct. Okay. So tomorrow ನಾವು ಇಲ್ಲಿ communication ಮತ್ತೆ semiconductors ಎರಡು ಒಟ್ಟಿಗೆ ನೋಡ್ತಾ ಇದೀವಿ. So tomorrow again semiconductor some questions, and along with that communications questions we will see. Okay. Yes, students. Okay, thank you. Have a good day.
Thank you, ma'am.